Okay, imagine we are building a weather station. It has a temperature sensor, a humidity sensor, and a pressure sensor. These sensors keep sending fresh weather data to our system. Now, obviously, just collecting data is not enough here. We need to show it somewhere. Maybe we want a screen that shows the current weather. Maybe another screen shows statistics like minimum, maximum, and average temperature. And maybe later we want a forecast display or a mobile app. So far, this sounds pretty simple. So we create a class called WeatherData. Whenever temperature, humidity, or pressure changes, this object receives the latest value. Then we create our first display, current condition display. And the easiest thing to do is just call the display directly from WeatherData. Something like weather change, so update the current display. For one display, this worked perfectly fine. It is quick and very easy to understand. And honestly, most of us would probably start from here. But then the product teams come back and they say, we also need a statistics display. And then we need a forecast display. And then can we also send weather alerts to a phone? This is how real software grows. One requirement becomes four requirements very quickly in real world. Now, weather data needs to know about every display. It needs to update the current display, the statistics display, the forecast display, the phone app, and any future display that gets added. Now we have a problem here. Weather data is supposed to manage weather data, but suddenly it is also knows everything about how every UI display works. If we add a new display, we have to modify weather data. If we remove a display, we modify weather data. If the phone app changes, there is a chance we also need to modify weather data again. This is called a tight coupling. The weather system and the display system are too dependent on each other, and that makes our future changes more risky, more annoying than they need to be. So let's think about this situation differently. The weather station should not have to know every display in detail. It should only know one thing. These objects are interested in weather updates. Think of it like YouTube subscription. A creator uploads a new video. You do not need to keep refreshing their channel every minute. You subscribe, and when a new video published, YouTube notifies you. Same idea will apply here. A display can subscribe to weather data, and whenever weather data changes, weather data notifies all subscribers. In observable pattern language, the thing that owns the changing data is called the subject. In our case, weather data is the subject. The objects that want update are called observer. So current condition display, statistics display, and forecast display are observers. One subject can have many observers, and whenever the subject changes, it tells every observer, hey, something changed, you may want to update yourself. A new display can join whenever it wants. It just registered itself with a weather station. It's in simple words, it subscribes. And if display is no longer needed, it can remove itself. Maybe the user closes a dashboard, maybe a client disconnects from a WebSocket, maybe the display weather notification. The observer unsubscribes. After that, the weather station stops sending updates to it. Now let's see how we can represent this in code. First, we create a subject interface. It has three responsibilities: register an observer, remove an observer, and notify all observers. Then, every display will implement the observer interface. It has one method, update. When weather data changes, it calls update on every subscribed display. This is the beauty of this design. Weather data does not need to know whether it is updating a phone, a dashboard, a graph, or a forecast algorithm. It only knows that every observer supports update. Let's walk through what happens when weather changes. First, the sensor reports new data: temperature, humidity, and pressure. Weather data stores the latest value. Then, weather data loops through every registered observer and calls update. Each display gets the new value and decide how to present them. The current condition display might show temperature and humidity. The statistics display might calculate average. The forecast display might use pressure trends. Same event, different reaction, and weather data does not need to change when we add another display here. So here there are two common ways to send information in observer pattern. The first is called push. So in push, as the name suggests, weather data directly sends the new temperature, humidity, and pressure to every observer. Then second one is obviously pull. In pull, weather data only says something changed. Then each observer asks weather data for exactly the value it needs. For a small example, push is very easy to understand, but pull can be more flexible when different observer needs different piece of data. For example, a statistics display may need a temperature history, while a simple mobile alert may only care if temperature crossed a threshold. So the weather station is just an example. You already use observer like system all the time. When you subscribe to a YouTube channel, you're an observer. When you order status changes and notification is sent, this is observer style flow. Then Kafka consumer react to a new event. The producer and consumer follows a related published subscriber idea. When a stock price changes and dashboard updates, this is the same general concept. In backend systems, you will see this is in notification, event-driven service, web sockets, message queues, monitoring system, and UI state updates. And now we can finally give this design a name. This is the observer design pattern. The observer pattern defines a one-to-many relationship between objects. When one object changes state, all of its dependent are notified automatically. The key takeaway is simple. If many things needs to react when one things change, do not tightly connect all of them together. Let interested objects subscribe, let the source notify them when something changes, and let them unsubscribe when they no longer care. This is the observer pattern. Thank you so much for watching this video. If you like this video, please like it and share it, subscribe it. Thank you. Peace.